securing application data. I'll again check. I think when we come up with, I would say, data, or when we come up with applications, most of our applications, as we have been discussing about how the storage and how the usability is going to be affected by being used by them, then data is important, and it is kind of the most valuable asset that an individual or that an organization possesses of, if we consider three scenarios. And it is not uncommon, I would say, to see monetary value assigned to that particular data, because most of the companies are now hiring data engineers or data science experts that can understand how the nature of data, or how the trend of data is going up or down.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
And based on the outcomes, they kind of are able to fetch out the suggestions that how business can be impacted, or how business can be affected by looking at those data trends. So the trends kind of helps companies to actually figure out what decisions can actually make them profit and what decisions can make them loss. And then they try to avoid making mistakes by looking at the assumptions that can be done by looking at the data. Right? So data is, I would say, the most valuable asset. And it is directly correlated with the monetary benefit that a company can get. Right? So additionally, data may carry a hidden cost of, I would say, hidden cost of lost, or you can say losing a potential revenue. So this makes data a primary target for hackers and frauds. And the first step to protect your organization's privacy is to understand the data that you need to protect. So the main, you can say, organization's privacy, or the main breaches, or you can say the main threats that can actually cause, I would say, losing the data. You need to understand that. So I would say that there are companies and there are organizations that actually works in terms of identifying, or in terms of you can say figuring out that what are the steps and what are the necessary things that can be done in order to save the loss of data. So there is, I would say, organizations such as GDPR, which stands for General, I think, Data Protection Regulation. So the GDPR are basically steps that are actually taken into consideration while securing the data that is actually being used from one way to another. And this is kind of European guidelines that have been actually raised. So GDPR is most, or you can say, one of the most complete and restricted regulations that has ever been written, and it is relevant beyond, you can say, services provided within the European Union, you can say. So it includes protecting passwords and credentials and algorithm keys. All of that particular thing is included to be followed as a daily practice in order to save the organization's data, or in order to protect the organization rather. So the main issue is that while your application and, I would say, system must know those credentials, they must be hidden to avoid unauthorized access. Which means if you look at certain scripts that we actually write down, then I generally use variables like username is equal to, and then we use input function, and then we say enter your username, and then we also use the same for passwords. So we say passwords is equal to input, and then again get that. We also use get pass is another function that actually turns off the echo. But no matter what, the data is actually stored in a variable. And if I then use somewhere that print passwords, then it is going to print out that particular password. So the fact comes up that whenever the data is actually being sent out onto the device or out onto the application or so, that application or device should be able to see that data or should be able to see that credentials, but your organization, or you can say your employees that are working in an organization, you being an employee as well, should not be able to see the data. Okay, only the authorized or authenticated persons should be able to see that particular thing. So that's kind of the main issue. And the credentials must be hidden to avoid unauthorized access. So there are multiple methods to protect your keys, and each one, I would say, has its pros and cons. And another aspect of data protection is only communicating with authorized parties, and authentication is kind of a feature that they needed to achieve it. So you also you might have heard about a term called PKI, being a network engineer, public key infrastructure, and it was there in the, I think, a bit of introduction was there into the associate course as well. So PKI is the architecture that is used to authenticate unknown servers such as public internet services, and it is also the standard that is used for certificate-based authentication. Right? You use digital certificates and you sign them from your root certificate, and then they get authenticated if the certificate is correct or not. So once the communication is flowing with the authenticated peer, then it is essential to encrypt the data as well, depending on the traffic flows are directed in a way that no matter where they're coming from, no matter where they're going to, the traffic is actually encrypted in a way that if someone tries to hack into something, then he should not be able to. Because if you look at network, let's say you have, I would say, a site number 10 and you have a site number 20, right? Now this is situated in London and this is situated in Dubai. When you have it in London and Dubai, your device or your employees are sitting over here, and then your Dubai employees are sitting here. They want to communicate, but it's not going to be a direct connectivity always between your London site and between your Dubai site, right? So you probably have, I'm just drawing some of them, but you definitely have lots of devices connected in one way or the other, and that actually makes your data go from here. So you generally follow practice of creating tunnels, right, from source to destination, which means if there is any attacker that actually tries to sneak into the data, then the attacker can, I would say, can fail in order to achieve that particular data. So he cannot really sneak into the traffic that is going or that is flowing inside the tunnel and modify or temper it. No. So that's kind of encrypting data inside. I mean, when we actually talk about CIA, confidentiality, integrity, and associate availability, the I stands for integrity, that do not let the unauthorized users or attackers or sneakers hack into your data and try to, I would say, manipulate it. So that's something that you can avoid it. Just a minute. So that's where actually these guidelines and the best practices of securing application comes up. And when you talk about that, the very first thing that we would be concerned about is data storage and protecting data privacy. Like we discussed, that we often end up storing our you can say passwords into our scripts and all, and they're accessible to users. So data privacy. Now you will first look at, I would say, ways of protecting data, and say there are two types of data you can consider as of now. When you think about the types of data, then you have data in motion, and then you have data at rest. So data at rest is basically the data that is sitting in your hard drive. But if you're trying to copy one file over the network to the other device or to the other side, then you definitely make that data travel from one location to other location. The example that I just gave you, that whenever these multi-site services are trying to send data, and if someone tries to capture that particular data, then in that case, you're basically, the attacker is trying to capture data from data in motion. So you need to kind of secure that as well. And when you look at that, then there is a protocol that is often used in order to secure the data at rest, which is called as TLS. Okay, which is transport layer security. So we basically secure our data at rest and data in motion by using transport layer security, and it uses the user's personal details handling for requirements like GDPR and data anonymization or data sanitization or so for logging in and metric collections as well. So data can be divided into data at rest and data in transit, and data at rest are data stored at physical disk or cloud or something like that, and data in motion refers to data being transferred from one device to another. So to protect I would say data, you can say that encryption technologies should be used to guarantee confidentiality and reliability of transactions and file contents. So this following encryption technologies also ensures the integrity of how data can actually be secured or so. And you can say that in the exam that will also ask you that how data actually is protected. So the encryption, or we can say whatever protocols are there, that there are encryption protocols, be it AES or be it advanced encryption protection or advanced encryption standards, and DES and all the other things, you can basically check those actions. So talking about another thing, I would say data can be protected, or data at rest can be protected when they are stored onto storage devices. So the storages can be in any form. It can be into there can be storage area networks, or there can be cloud services, and they must be protected when they're in motion. So to protect the data, it means to guarantee confidentiality and integrity, and you can say authenticated access to them, right? Moreover, you can say there are specific regulations about how the data should be available and how the data should be accessed. So you have a set of guidelines that is available over there, which is called as PII handling. PII handling. So this PII handling stands for Personal Identifying Information Handling. And there are different regulations and guidelines applied in multiple countries. And by different regulations, there are different regulatory bodies, and there are regulations that are followed for handling the personal information. So the NIST that we have discussed, National Institute of Standards and Technology, they have published a guide for protecting the confidentiality of PII. In 2018, they did that over there. And the I would say GDPR, which is the most significant standard in the history of PII processing regulations, because it applies to Europe as well as any other country that wants to provide services or goods to individuals within the Europe. So the number of individuals and organizations affected by GDPR is larger than any other organization or any other regulation that is available there. So when we talk about the definition of PII, then it's quite similar across different standards and regulations that are followed. But I would say that there are, I would say, definitions that are followed, which means that you can say one which is called as one of the boundary or one of the rule that is followed is consent of the data. Or you can say data subject. So consent of the data subject is kind of considered there, which means that any freely given or specific or informed, or you can say unambiguous indication of data subjects wishes by which he or she, or by a statement, or by like clear affirmative action, signifies the agreement of the processing of personal data relating to them. That means that the owner of the PII must be clearly informed about the use of that particular data. If you heard about some of the scandals that have happened in the US elections, or that have happened into even UK and all, then there were companies that were involved into using data that was collected by Facebook, okay, and data that was collected, I would say, by Google as well. Which means that whenever you agree to terms and conditions, like when you deploy an application or when you deploy something, then there are, you can say, agreements that every individual or every user of that particular data kind of signs into. And they agree to let the collector or to let the developer of their organization use the data that they are trying to use. So the company has full right to access the data that they are provided a possession of. So if that company who has access to your personal information, and the information will kind of be in bulk, so that company, I would say, if they are willing to, you can say, give that particular data to someone else, then in that case, that's kind of a data breach that we consider. And that means that the owner of the PII must clearly be informed about the use of that particular data, and they must explicitly consent to that usage with the owner of that data. Because if you heard, or if you have started using website nowadays, every I would say the example of this, or the action that has been taken up, is the cookie banner. If you browse through any website, then there is agreement from the user that has been taken, or that is being taken by now, that whenever you visit a website, you are actually being asked that this website uses cookies. Are you okay with the developer sending cookies on your mobile? And when you actually allow them to send cookies on your mobile, then they can actually ask their cookies to sit on the phone, and then tell about or inform the company about the behavior of the user. And then based on that behavior, you kind of get thrown with the advertisements and all the other things. That's how you can say consent are basically taken. But again, most of the users do not really think about agreeing that particular data policy or not. Just everyone just says okay, and then everyone wants to just proceed further to visit the content that they're looking for. Apart from that, there is another thing that is considered into the standards or into the regulatory body, that is personal data breach. Okay, so when we say personal data breach, personal data means like breach of security leading to accidental or unlawful destruction or loss or alteration of unauthorized data. If you think that whosoever is looking forward to access that particular should not be accessing the data and should not be exposing that data to any unauthorized entity, be it organizations or individuals or group of individuals, that's kind of personal data breach, I would say. So the main consequence of the definition, which is personal data breach, linking it to the requirement, is to inform the users about the data breaches. Means that anytime there is any loss or modification or data theft, users have to be informed, resulting in a potential loss of reputation of the organizations, you can say, victim of that particular breach also. So if you're not being informed about the data breach that have caused in a company where you have put your data, that's again kind of a data breach, I would say, because you're not aware about that breach, and company is willfully, knowingly not taking actions to notify you or to do anything against the breach. It's basically sitting idle over there. I mean, there are definitely statements that are invoked as soon as there is a data breach, that our servers are secure and our storage is secure and all of that. But still, the data is kind of a data that is lost. Data breach over there. Now, if we talk about so the third one is filing system. Now, filing system basically means that any structured set of personal data that is actually accessible according to specific criteria, be it like centralized or decentralized or dispersed on a functional or geographical basis. The definition of filing system is broad, and it involves like local data storage systems as well, and the cloud as well. So wherever they are installed, wherever the storage is actually installed and active, including outside the Europe, the definition implies not only that the European citizens or the like must be processed according to the standards, but it also involves that the organizations that are actually free to store data everywhere in the world, if the principles kind of are guaranteed, if the GDPR principles are actually followed. So the filing system actually allows you to announce yourself that you are following that particular standard. But since the standards are actually made by Europe or European, I would say, regulatory body, if the standards are not being met, or if the data is actually being kept outside of Europe, then there shouldn't be anyone claiming that we are not following the, you can say, regulatory, I would say, restrictions by you can say not just putting or not just physically keeping the data in the Europe. So it doesn't matter if all of that particular data is not in Europe. If you're a company who operates in Europe, you gotta work with that. That's kind of PII handling and the concerns that comes under that particular thing. And then there are other factors also that are involved, which are transparency, legality, minimal data gathering, or you can say time bounded by that. So transparency means that the controller clearly states the scope of the reasons, or the scope and the reasons behind that, like PII gathering and messages them accordingly with that particular like data subject would expect or show. And legality means that the process is related only to what the data subject explicitly consented. If the user is not aware about where the data is actually being used, then that's kind of illegal. So the user always should be notified about where the data is actually going to use or so. Shown to the user or so, you should always keep it in secret. That's why most of the people uses PKI, which is public key infrastructure. Now, you can say you look components of a working public key infrastructure system and its benefits and challenges, including like certificate authority chains, and certificate you can say revocation list and all. But a PKI highly, you can say, facilitates a scalable trust relationships, and PKI can be further, you can say, scaled using a hierarchy of CAs. And certificate authority. So majorly there is one key term that is used, CA, which is called as certificate. Just a minute. Which is called as certificate authority. So certificate authority is an entity, is an organization about which or on which, if someone is actually trying to state that they are, you can say, legit users or they are legit organizations, and if the legitimacy is approved by a trusted certificate authority, then every other entity kind of trusts that whatever the user or whatever the organization is claiming to be, it's correct. There is no like false information that is available there. So that's how they can actually be ensured. The PKI is an example of a trusted third-party system, and the basis of the trust is the CA's public key, the certificate authority's public key. So that's why it is called as public key infrastructure. So all systems that leverages PKI must have certificate authority's public key, and certificate authority kind of announces its public key that is visible and accessible to everyone, and it is present into most of the web browser. If you've heard about VeriSign is one of the certificate authority. Amazon is another certificate authority. I would say GoDaddy in India is another certificate authority, and there are numerous authorities that actually are identified as legit use or legit, I would say, stampers. So every web browser is aware about the public keys of these trusted root certificate authorities or certificate authorities just. So the CA's own identity certificate is unique and it is self-signed because certificate authority kind of gives a certificate or you can say they give a certificate that is like publicly signed over there or they like it is self-signed and it accessible to the public generally. And for many systems, the distribution of CA certificates is handled automatically. For example, commercial web browsers come with a set of public CA root certificate pre-installed. And organizations push their private certificate authority root certificates to clients through various software distribution methods or so. So in some instances, particularly like when a system needs to enroll with a PKI to identify the certificate for itself, the CA certificate must be requested and installed manually, which means if you kind of understand how that particular thing works. Let's say you have a web server, and then there is this admin that is available. Now, if you have, I would say, certificate request, and then there is this CA, okay, certificate authority. So how it works is basically, and there is, I would say, someone who, so what this particular admin is going to do in order to access the service or so, this CA, there is other entities, for example, customer B, customer C, and customer D. And these customers wants to access the services that are hosted onto web server. But when they are trying to access that particular data that is actually hosted by this web server, can they trust the data or can they not trust the data? That's kind of a question. So this web server actually needs to prove its identity that whatever data that the users are trying to access, the data is completely safe. There is no such issue over there. And for the same reason, I would say how it works is initially web server kind of generates a CSR. CSR stands for certificate signing request. The certificate signing request contains information about the web server, the organization name, the date of establishment, you can say the services that the organization provide and lots of other data. Okay. And that certificate signing request is actually sent to CA. CA verifies if the certificate should be signed or not, and then it kind of grants a certificate, and that certificate is installed onto the web server. So whenever the customer B, C, and D will be trying to access the resources that are there, they will first check whether the web server has the signed certificate installed or not. If the signed certificate is installed, then the you can say customers will kind of trust on that particular thing. So that's kind of how it works. So to obtain an identity certificate, which is kind of a signed certificate that they can produce to their customers or so, you can say the first step is to obtain the identity certificate itself, and then the CSR kind of needs to be approved and so. So when the signed certificate is made available, then I would say you can prove your identity is legit and you are being trusted by the CA itself. That's how a normal PKI servers and all are signed over there. That's how we can say certificate authority and certificate signing actually works. And PKI is a very popular way about how certificates can actually be handled and how it can be installed or so. So majorly, if we look at the process, if I give you an example about how that can actually be done, let's say that there is resources that are hosting on some of your headquarters. And in that particular headquarter, what you would see is you would see some resources, like there is server 1, then there is server 2, and then there is server 3. And this server is actually made available via network to be accessed by some of its customers. So you have customer 1, customer 2, customer 3. And if you connect like it with internet, no matter where they are situated or so, the users can actually access most of the data that is stored over here, or any combination of you can say data. In a way, only and only if the web browsers that are actually being used by these customers trust the data entity or not. So for the same reason, what companies do, they actually install, I would say, a certificate authority. And that particular, like you can say, this is going to be enterprise certificate, right? This enterprise certificate is actually installed into all of the devices or their operating systems. And once they have that particular local certificate installed, and they kind of sign all that certificate, once the granted certificate is there, then whatever certificates that they produce to the user, that this is our certificate, this is signed by whatever certificate authority that they're using, they will check into their web browser that the you can say CA is considered as a trusted CA in by our list of CAs that we trust on by our browser or not. If the browser that is actually being used by the user trusts onto the same root CA that has been used by the user to sign its certificate, then the page is verified. If the pages that are actually are signed by a root CA, but if the browser does not trust that CA, I mean, if the browser does not have a valid list of, you can say, valid list of public certificates or public key certificates of all the root CAs, then the page is not going to be loaded. It is going to be disapproved by that. So that's something that can actually be considered. So you get browser security warning, and you get lots of other warnings as well in that, where you can say you need to say we basically go into advanced, and then we say proceed by not just our browser prompts us that the certificate is not valid and it is not verified by the browser. What would you like to do? Would you like to terminate the session, or would you like to move on? So we generally go through that particular scenario. And after that, you can say that's how PKI overall in general terms actually works out. And after that, the second section which we have is securing web and mobile applications. So when we talk about mobile applications, or when we talk about web applications, then modern web and mobile applications require security to be considered from the beginning to ensure the, you can say, highest level of privacy and security on the web. And this result can actually be achieved by using trusted open standards and implementing, I would say, well scrutinized and best practice solutions. So for the same reasons, there is an organization, you might have seen it in Associate as well, which is called as OWASP. So OWASP stands for OWASP stands for I would say Open Web Application Security Organization. And this Open Web Application Security project is kind of a project that has been catered by an organization that announces the top 10 threats every, I would say, year. So the popular term that is available over here is OWASP Top 10. And the OWASP Top 10 is kind of list of 10 current and most dangerous web application security flaws that are available. And this application security standard is published and maintained for free by OWASP Foundation, which came into being in 2001. So it provides free and open application security tools, standards, books on secure development, testing, and code reviews. Okay, and there are lots of like presentations and videos and A lot more stuff that is available that you can use for study purposes. So it's more like a research organization onto security flaws. And all OWASP tools and content are free to be used. There is no payment that you need to make to use those particular things. So you can say the top 10 list was originally published as a tool to raise awareness, but it has become kind of the de facto security standard for web application development. And the document is published in English, French, Chinese, German, Hebrew, Japanese, and lots of other languages as well. So the list includes most dangerous vulnerabilities, and it aims to raise awareness, or you can say forward toward the threats that are available. So attackers kind of try to breach or hack someone's data by one or the other way. And there is always there is no end to the methods that users can try to get into a network or so. There is always going to be flaws. If there is going to be a resource available, then there are methods to access it anyway. So it's all about going or keep going for securing the data that you have available over the network. You never can say that the data is secure and no one can hack it. That's not a possible statement. So when we talk about the OS security, then there is, I would say, the list includes most dangerous and famous vulnerabilities that are there, and OWASP kind of rates it. There is a rating factor that is actually used. So the risk rating system for the OWASP top 10 is based on the methodology that is used, and for each top 10 category, you can estimate the typical risk that each weakness introduced by looking at the common likelihood factors and impact categories from each risk or so. So if you kind of look at how or if you can look at the factors that are basically considered, then the risk factors or risk rating factors that are involved are: one is its exploitability. Then you can say the second one is weakness prevalence. The third one is weakness detectability. The fourth one is technical impact. And these are most of the, I would say, factors on which there is a score that is calculated. So each item in top 10 is assigned a score across these four categories by OWASP. And the threat agents and you can say business impact categories, which are also over there, and you can say they are not really considered that how the business is actually going to be affected, because it's most likely depending on what type of business it is or what is the nature of the business also. So when you can say how the scoring actually is done. So the scoring is done by a methodology which is calculated as for all these factors, you would say likelihood multiplied by impact, and that is equal to risk. That's kind of a normal formula that is followed. So when you work about how I would say likelihood or how these things can be considered, there are ways about how you can consider that. So if you talk about how the identification of threat is done, because that's going to be the very first method or very first process towards rating something. Is it really a threat or so? So identify the actual risk and the vectors, like this is application and business specific or so. And then if you talk about the factors for estimating likelihood, then they talk about what's going to be the skill level, or the motive or opportunity size and ease of discovery or ease of exploit and the current awareness on that particular exploiter. So they consider factors like these. When you talk about how they can like estimate the impact, then they go through like loss of confidentiality, loss of integrity, and loss of availability. Okay, the CIA tried, and also the financial damage is considered when they calculate the impact of that particular attack. So once they kind of the likelihood and impact are known, then the severity can actually be calculated, and then the team kind of researches on how to fix what can be the mitigation to the risk and what can be mitigation to the threat that they are announcing as a major threat or so. So that's kind of a scenario that can actually be considered. So if there is a threat, and for example, out of the rating, when you consider it in a way, like let's say the exploitability or exploitability of a threat is, let's say, 3, and then the weak prevalence or is again 3, and the weakness detectability is again 3, and you can say the technical impact, I would say, is 2. Okay, that what's the impact that it's doing. So they basically calculate the average of this, which is basically 3, definitely, and then they multiply it by 2. So 3 by 2 is 6, and 6.0 is going to be rated for that particular threat. So if you are able to rate that, and that's basically done based on the outcomes of some test that they do. There is no such question that is going to be in the exam that this is a threat, this is how much it's causing you, calculate the risk. That's not going to be a question at all. They basically consider the factors by their own, and then they rate the exploitability, the weakness prevalence, and the weakness detectability based on their research and so, and then they calculate it. There's no such rule that they follow or so. And and if we talk about the top 10 risks, that definitely is going to be asked in the exam, but it I would say involves OWASP, or rather then one of that is injection. The second one is broken authentication. The third one is sensitive data exposure. The fourth one is XML external entities. Then the fifth one is broken access control. The sixth one is security misconfiguration. Misconfig is a major thing that is caused into industry. Seventh one is XSS, cross-site scripting. The eighth one is data deserialization. The ninth one is insecure, or I think vulnerable components finding. And then you have missing logging and monitoring. If you don't have a login and monitoring on, then you are not going to get to know about these particular threats also. So when you actually talk about these threats that are available there, then you can say you should avoid them pretty much over there. So injection and all of these methods, like injection is something that by using a structured query language or SQL queries, someone can actually sneak into the database and someone can program that particular database in a way that the operating system can be managed, or that an authentication system can actually be manipulated or so. Such kind of things can be done just by doing injections of SQL scripts into the application or into the program, and it's kind of severe over there. Broken authentication means the user is actually not changing the default credentials that are being used, and you need to fix that particular thing. Since no one in the production doesn't really work with the default, you can say, usernames or password, but if still you are doing so, then you are at great risk. Sensitive data exposure, the name itself suggests that when the data is actually leaked, it can also be leaked by a person, it can also be leaked from a device. So people also try to fetch information from persons by giving them money or by giving them bribe or something like that. That's kind of data exposure. XEE, which actually stands for XML external entities. It's about you can say supplying an XML data or XML payload that can actually breach the current application's behavior, and it can expose some of the inside information to the user or so. The broken authentication again, broken access control. It's kind of, it can be a physical failure that your data center is actually situated in a location that it can be accessed by someone by just opening the door, not by entering in it, so that they can be hidden from the camera as well. And the power switch is kind of exposed physically in a way that anyone can power on your devices or on your servers, and anyone can power it off. So that's kind of a limitation that can be, so not a limitation, a vulnerability that can be there. So you should always plan your physical things, like access point is not working, the fingerprint scanner upon verifying which the door opens up is not working, or the biometric is failed. All of these particular things comes under broken access control. The security misconfig can definitely be the configuration failure that the network engineer or the security guy have not implemented security configuration in the best way. XSS, which is cross-site scripting, is again a type of attack that is actually conducted by hackers and all. The vulnerable components are physical components, or you can say technical components, that actually allows a backdoor entry to user in order to, I would say, hack something or fetch out data from that. Missing logging and monitoring would kind of not leave any traces if there is any failure or so. Because when we kind of discussed about software development lifecycle, or even the NIST definitions, then there was proven over there that the attacks, or you can say whenever the attack is actually done, your detection system should actually know that there is an attack that is happening, or there is an attack that has happened. If your logging or monitoring systems are not having track of that, you will be at a big loss. So these are some of the, I would say, top 10 threats that are available over there, and you kind of work toward fixing all of these particular things. So that's, I would say, the content that is there to be